Hello students, today we are going to start another chapter of your book Wave Optics. The objective of today's topic is to study about wavefront and Huygens principle. And the topics which we are going to study about are wavefront, types of wavefront and Huygens principle. Let's start our topic. Wavefront. Before discussing the wavefront, let's see what is a wavelet. A wavelet is the point of disturbance due to propagation of light. So these dotted points which are in pink color, they shows wavelets. It gives rises to the next wave, or you can say next disturbance. Now, a wavefront is the locus of points having the same phase of oscillations. And third definition is a line perpendicular to wavefront is called a ray. So here we can see there are three types of wavefronts. First one is the spherical wavefront, second cylindrical wavefront, and the third one is the plane wavefront. Remember, whenever there is disturbance which is just of point size, or we can say that there is a point source, the whatever wavefront originated from a point source is spherical. Whereas if source of disturbance or source of light is linear, then the wavefront originate from such source is called cylindrical wavefront. And the third one is the plane wavefront. Let's discuss each wavefront. The very first is the spherical wavefront from a point source. So here in this animation you can see this red dot is the point of disturbance, and the disturbance goes throughout the three dimensions. So it gives rises to a spherical wavefront. Next is the cylindrical wavefront from a linear source. So it looks like this. The center one is a line disturbance or linear source which gives rises to cylindrical disturbance or cylindrical wavefront. And the third is plane wavefront. So plane wavefront is the wavefront which travel throughout the medium as a plane. You can see here through the animation it can be easily visualized that a plane wavefront is the disturbance which travels in the form of a plane. Remember, to get a plane wavefront you need a point source or a linear source, but it should be at a very far away from you. Now next see Huygens construction or Huygens principle of secondary wavelet. So Huygens was the scientist who told about how waves originate or propagate in a medium. Here S is the disturbance, which is the first point source which gives rises to the disturbance, and the disturbance travels throughout the medium in all the direction. So here we can see next is the new wavefront which originates from this point source S, and it travels throughout the medium and ultimately it gives rises to a plane wavefront because the source is very much far away from the new wavefront. Then we call it as plane wavefront. So here red dots on the wavefront is the wavelets. So these are the wavelets which give rises to the secondary wavelets. So according to the Huygens, the very first point or very first principle of Huygens is each point on a wavefront acts as a fresh source of disturbance of light. So whatever be the points we have drawn here, we can draw this point here also, or we can draw a next point here. At every point, this point gives rises to the next disturbance. It is a fresh source of next disturbance. Secondly, the new wavefront at any time later is obtained by taking the forward envelope of all the secondary wavelets at that time. So these wavelets, these points are in the same plane, and if I am going to draw an envelope, it gives rises to the new wavefront. So if I am going to draw a line such that it covers all these wavelets, then we call it new wavefront. Now the question arises, why backward wavefront is rejected? Why waves are not traveling in backward direction? The reason is Amplitude of secondary wavelet is proportional to half 1 plus cos theta. So this is the relation for the amplitude. Now obviously for the backward wavelet, theta is equal to 180 degree. If the wave is traveling in the forward direction, then theta will be 0 degree, and we know that cos 0 is 1, 1 plus 1 gives us 2. But here if wave is traveling in backward direction, then theta is equal to 180 degree, and we know that cos 180 is minus 1. So plus 1 minus 1 cancels each other and we'll get 0, means 0 amplitude. So no wavefront is traveling in the backward direction. Okay. So here you can visualize that this disturbance give rise to the secondary wavelets, then to the next and next. Ultimately, it travels in the forward direction. So here one more animation is there, like a stone which is thrown in the water. The ripple formation is very good example of formation of wavefronts. So now you are able to answer these questions. Question number 1, what is a wavefront? Question number 2, name different types of wavefront. Question number 3, what kind of wavefront is formed by a point source? Question number 4, what kind of wavefront is formed by a line source? Question number 5, what kind of wavefront is formed by a distant source? These two questions are very important and usually examiner asks this question from you. And the 6th question is, draw the diagrams for different kinds of wavefront. That's the end of the topic. Thank you.